Hello and welcome back. We are well underway on finishing up this year. We only have a little less than a month left in this year, actually. Um, it's been a year. We're gonna get through the rest of it. So, a couple of quick announcements, a couple of quick things you should probably go over. First off, please make sure that you are completing all of your homework by Monday at noon. That is the official due date for all of your work. I cannot start grading until that time, so please do your best to get that work in. Um, Make sure that you are doing all three assignments for the week. I'm uploading all three on Tuesday at 8 a.m. You should have all three of the assignments available to you at that time. So please make sure that you are completing all three assignments for the week by the next Monday. Um, Also, while you are working, please make sure that you are showing all of your work. As a note, and I will post this on Classroom probably later, uh, probably today sometime. Please make sure that you are putting your answers on the uh, projected sheet, on the homework sheet itself, and then posting a picture of your work for later. That way it's just easier on me so that I can see, oh, answers right there, cool, and then your work, just in case your picture gets cropped or some other formatting issue and I can't see it. So, just please make sure that you're answering your uh, answers onto the actual homework sheet itself and then posting your notes. So, do both. So, our topic for today is actually not that bad. It's almost exactly like our topic from last week. It's just a one slight difference that's going to cause a lot of hiccups. So we're going to try and hit as many of the um, issues today as we can. And as always, I'm always available to you in email. And if you really need to, I can open up a Zoom meeting at any time. Um, I generally don't check my email after like 8 o'clock, but generally anytime in the morning and afternoon, I'm available to you. So let's get to work. So, so we have molarity. This should look very familiar to you. You don't even have to take notes over this because this is the exact same slide that we saw last week. I just want to refresh your memory of it because it's going to look incredibly similar to something that we're going to have today. So, molarity is an expression of the concentration of the solution in moles of dissolved solute per liter of solution. Basically, what it's saying is that its molarity is equal to moles of the solute, or what we care about, over liters of the entire solution after the moles of solute is dissolved. So that is what defines molarity. It's very useful to us because we only need to have this many liters of solution. We only need to have this many moles of solute. We really don't care what we're dissolving it in. It's very useful in that case. So, why am I bringing this up? The reason that I'm bringing this up is that we have more than one form of concentration. Molarity is one form. It's the most common form used in a lab. But there are other forms of concentration that you're going to find throughout your life. So I'm going to teach you another one today. That other form is called molality. Now, I know all of you are hating this automatically because it's molarity and molality. That's too similar. I agree with you. But however, I'm not in charge of naming this thing, as I've said many times. So, molarity is a way that scientists express the concentration of something in a lab. Molality is something that is more useful towards industry. So, whereas molarity, we're dealing with small quantities, maybe up to a liter's worth of solution. Molality, they're dealing with they're dealing with quantities in tons. So that is why molality is used because it can actually be used. If you ever notice the salt trucks that are dropping um, the saline solution on the roads during the winter, They are dealing with a molality concentration of the salt that they're putting on through the roads. So this actually is used in your life. You'll probably see molality somewhere around probably somewhere in or around your home. If you look hard enough, you'll actually see most of these terms. You just haven't noticed them up to this point. So what is molality? Molality is the concentration of solution. So we already know it's a concentration. That's fine. Expressed in moles of solute. Same thing. Exact same thing as last time. Per kilogram of solvent. Now here's where things get different. In molarity, we cared about how many liters were there at the end product. The end product was 1 liter. The end product was 2 liters. That doesn't matter as long as we knew what the end product was. For molality, we don't care about that. What we care about is we care about the weight of the solvent, not the solution, of the solvent. So, molality cares about the solvent specifically. And of course, it cares about the moles of solute as well, but it cares about the kilograms of the solvent because it's a more accurate way of depicting how much solvent is actually in there. It's easier to weigh out tons and tons of water than it is to measure out specifically how much water's in there by volume. So that's why we use that's how molality is different. So, like I was saying, molarity is liters of solution. Molality is the mass of the solvent. Now, something I want to point out to you. Molarity is big capital M, and molality is little lowercase m. If you notice, we throughout the year we've had a lot of different M's used as abbreviations. That's because M is a very common first letter for scientific words. Just try to make sure that you know which one is which. Molarity, which is the one that we use in the class, which is the one we use in labs if we ever had a lab, it would be in molarity. Molality is one that you would see outside in industry and that sort of thing. Molarity, liters of solution. Molality, mass of solvent. Okay? So, what's the real difference between these two? When they're dealing with smaller quantities, smaller molarities, smaller molalities, they're actually very, very similar. It's just when you get to larger quantities that the two start to separate out. So, let's take a look at a couple problems. So, molality practice 1. A solution was prepared by dissolving 9 grams of sugar, C6H12O6, into 125 grams of water. What is the mole concentration of the solution? So, we need to look at our equation. It's tiny m is equal to moles over kilograms. Okay, so let's look at what we have. We have grams of sugar and we have grams of water. So let's look. We have which one of these two is going to be our solvent? Our solvent is going to be our water because it's what's dissolving. What's going to be our solute? Our solute is going to be the sugar. The sugar is what's going to be dissolved in the water. So the sugar is going to go on top while the water is going on bottom. Now, water is usually going to go on bottom. I'm going to just tell you that right now. It is considered the universal solvent. So, if it's the universal solvent, it means it's probably going to be on bottom almost 99% of the time. 99% of the time, and almost 100% of the time in this class, water will be on the bottom for these problems. So, we have 2 units. Well, we actually have 1 unit, but we have 2 units in our problem, moles and kilograms. Neither one of those is grams, so we need to do a quick conversion. So, we have 9 grams of sugar. In this case, we're using glucose, C6H12 0.06. Well, if I have grams right here, we need to put this in moles. How do we go from grams to moles? Molar mass. So we have grams right here, we have grams on bottom, and moles on top. I'm just going to put the little abbreviation things. So how many grams of C6H12O6 go into 1 mole of it? Well, if I look at my handy dandy calculator, I know that oxygen is 16. 16 times 6 is 96. Plus 12 plus 12 times 6, which is 72. So if you add all those up, you should get 180. Now, I did this very quickly. Make sure that you are using to the hundredths place, just as you would in the classroom. So, 9 divided by 180, and you get, I typed it in my calculator wrong, 0.05 moles. So, you have 0.05 moles of sugar, and we're going to put that over the kilograms for the water. Now, this one's a little bit easier. You have 125 grams of water. How do we go from grams to kilograms? Well, there are 1,000 grams in 1 kilogram. So, kilograms is going to be smaller. So, I'm going to divide 125 by 1,000. Meaning I'm going to take 125 and move the decimal place over 3 spots. When I do that, I get 0.125 kilograms of water, which, when I take 0.05 divided by 0.125, gives me an answer of 0.4 molal solution. See? That's not too bad. This is the type of thing that you're going to be doing this week. It's not super difficult. So let's take a look at another one really, really quickly. Okay, so we have what is the molality of a solution made of 35 grams of NaCl and 200 grams of water? So I'm going to go ahead and say that 200 grams of water, and I'm going to put that into kilograms automatically because of my solution, my equation. So grams to kilograms, just divide by 1,000, or just move the decimal place over 3 times. So 200 turns into 0.200 kilograms. Now that's all that's left is turning the grams of NaCl into moles. So all I got to do is say 35 grams of NaCl, grams on bottom, moles on top. Now, I don't have NaCl memorized in my head, so I'm going to go ahead and look at my P table and see that sodium is 22.99 and chlorine is 35.45. So 22.99 plus 35.45 gives me 58.44 over under 1 mole. So 35 grams divided by 58.44 gives me 0.5989, etc. It keeps going. But for this, make sure that you're not rounding in the middle. You need to make sure that you keep all of that in your calculator so that you can divide it by 0.2 and get 2.99 molal solution. With sig figs, that should actually be 3 molal, but we'll take it. So That's actually all it is for this week. I'm going to upload some more practice. Stay safe, stay inside.